Hi, welcome back to LeetCode. So in this video, we discuss LeetCode problem 3607 power grid maintenance. So you are given an integer C representing C power stations, okay, each with a unique identifier ID from 1 to C. Okay, 1 to C, there are C substation, power station are there. So these stations are interconnected via n bidirectional cables. So represented by a 2D array connection. So where each element connections I represent UI and VI indicates a connection between the station UI and VI. Stations that are directly or indirectly connected from a power grid. That means suppose we actually have C is equal to 5. 5 number of stations are there. So this is this 5. So this is 5. I am to say that this actually connected, and these two actually connected, and these node 2 are connected. Okay. Now what they are trying to say that this connected component actually form a grid. This actually one grid, and this actually another grid. Okay. Now next they are trying to say that initially all stations are online. Okay. So you are also given a 2D array queries where each query is one of the following two types. So type 1 is 1, x. So a maintenance check is requested for station X. If station X is online, it resolves the check by itself. If station X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. If no operational station exists in that grid, return -1. Another type is 2, x. Station X goes offline. Okay, so that means this is non-operational now. So return an array of integers representing the result of each query of type 1, x in the order they appear. That means suppose our C is equal to 5 and there are 5 nodes are there, power station. These 5, suppose this is 1, 2, 3, 4, 5. Suppose these 2 are actually connected, 1 and 4 actually connected, and 2 and 4 actually connected. Okay. Another is 3 and 5 is connected. So there is 2 power grid. Okay. So initially all are actually online. So all 5 power station will be online. So that means true, 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 true. So that will indicate online. Okay. So next is suppose our query is 1, 2. That means type 1. So power station number is 2. So I want to know that which actually can solve the current problem. So this 2 actually is online. These 2, 1, 2, 3, 4, 5. Yes, 2 is online. Right? 2 is online. So 2 can solve itself. So our answer for that will be 2. Next query, suppose 2, 2. Now what will happen that 2 will be now false. This is now offline. So I'll mark this as false. Correct. Next, suppose our query is 1, 3. So that means I want to query that like for this power grid 3. So who can actually solve my current problem? So first it will go to the node number 3. So I will check that is this online? Yes, it is online. True. So that means power grid substation number 3 can solve itself. So our result for that it will be 3. Next, suppose I got query of type 2 and node 3. Now what will happen? I will mark the node 3 or the power substation 3 to false. Now it is non-operational, right? Now it will false. False indicates that this is not this is offline now, not online. Now next query, suppose I got 1, 3. So first of all I will come to this node 3. So this substation is online? No, this is false. Then who can solve this my problem? It will be the substation is present in the current grid. So this is actually one grid. this is one grid and this is actually another grid, right? This is another grid. So 3 is part of which grid? This grid, right? This green color. Now I have to check that is there any other substation present that is online, right? Okay, so any other substation? Yes, 5 is present and it is also online. So 5 can solve this, but I have to choose the minimum ID, minimum ID. So okay, there is no other option. So our answer will be 5 for that. Clear? For this, our answer will be 5. I got actually 1,3, but our answer is inserted as 5. Clear? Why actually it is 5? Because 3 is offline. So I will check any other actually nodes is present actually online, and I will choose the minimum one of minimum of them. Right? Clear? Next, suppose I got one query 1,2. Okay, so I will go to the node 2. Okay, node 2, this is actually online. No, this is false. So 2 can't solve the current query. It cannot resolve the current query. So who can actually solve? So I'll check other power station present in the current grid. So current component which node is present? 1, 4. This is actually online. 1 and 4 both are actually online. Yes, 1 is also true and 4 is also true. So that means it can be solved by 1 or 4, any one of them. But what should be our answer? I have to choose the minimum one. So our answer will be 1 for that. Clear? The problem is clear. How actually getting the answer and what I have to do? Query 1, query 2, type 1, type 2. Clear? So that means what is the brute force approach we can think actually? The steps I want to follow. First of all, I have to take one online vector of n size that will be true, initially true. Now I will also know, or I have to know also now the group ID of any node. So that means it indicates that for ith power station, part of which component, right? I have to know that, because if suppose this ith power station is offline, then whom it will who can actually resolve that query? So it will be the other substation part of the current component, right? So that means I have to ultimately know that this is our suppose graph, input graph. So I have to know that for this, suppose our group is 0, this is also group is 0, this is also group is 0, this is part of group number 1, and this is also part group of group number 1. So I have to identify that. Next, how can I identify that? I can actually visit the graph by using the count number of component or sub component. So that means I will take, like you can also solve another problem, that is a famous problem, count number of sub components in a graph. So I will take one visitor vector. So it will initially mark that all are actually false. I have not visited any node till now. So I'll check this node 0, is it visited? False. So I'll start visiting from here. So I'll check that which node actually other nodes actually part of the current component or current hierarchy. So I will mark all of them with the current ID. Suppose this 0, 1, 2, 3, 4. Suppose 0, 2, 3 is part of current component. So I will this vector group, I will mark this with this group 0, 1, 2, 3, 4. So in the group 0, index 0, I will mark this, okay, it is part of the current group 0. Next 2 is also part of the same group, so it will be marked with 0. Next 3 is also part of the same group, so I will mark this as 0. So this indicates that all these nodes actually part of the current group, alright, group number 0. Now next, okay, this is actually visited, now true. Next 2 I have also visited and 3 also I have visited. Okay, next I'll go to the next. For the visited is equal to I is equal to false. That means I will start visit from that node. So this is actually node number 1, it is still false. So I'll start visiting from here and I'll check that which node actually I can reach from the current node in the current hierarchy. So I'll mark all of them with true. Okay. Now also again I have to modify the group vector also. Actually I will identify that the current node 1 is part of the group number 1. Suppose 4 is also part of the current group. So I'll mark this also 1, right? So from this, after this visitor, after visiting all the node, from this in this way. Actually, from this group vector I can easily say that node 0 is part of which grid, then node number 1 part of which grid, then node number 2 is part of which grid, right? Now which it will helps me to identify that suppose our 2 is offline, node 2 is offline, then I'll check what is the group number. Okay, group number is 0, group number 0. Okay, so I'll check that which node is part of the current group number 0. So I have to state another map also against the group ID, that which node is part of that. Suppose X, Y, Z. Suppose this is actually part of the current group ID, this group number 0. Okay, suppose that means I need actually group vector to identify the what is the group ID for any node, and I need our map to know that for this group ID which node is part of the current group ID. This can be multiple nodes can be part of the current group, any group. So that's why I have to know not any set or any data structure, so I can store them multiple values. Correct? This is clear. So I need to two things. One is the online or offline. So that's why I need to another vector of size n, a group. It will actually from this visitor the count the number of sub components in a graph. That from that actually I will get that that which node actually part of which group. Okay. Then I will store that in this map, that I will store that from this group ID which actually part of the which node is part of the which group. So I will easily say it will helps me in the type 1 query, right? This is a type 1 query. Yes. So I'll check that if it is offline, then I will go to the other nodes that it can actually resolve. So I will check from this map. Otherwise I have to again visit this group ID again. That will again take big of n. If I again visit that, okay. Suppose if I do not want to store in the map, so what will happen? I know that from this group of X, I can easily know that what is the group ID. So then actually I will traverse all the nodes, all the position of the group. I will check that okay, this ID is equal to ID. Current ID is equal to ID. The X ID of X. So this is part of the current group. So I'll check that is it again online or offline. So it will take big of n, right? So it will take for each query. I have to traverse all the nodes and check that this is actually online and also part of the same group. Whatever to consider online and also part of the same group, right? So this will actually give us the n square number of queries, and for each query I have to traverse all the group, all the nodes and check that which group actually which node is part of the current group. So for that optimization I can use the map that okay, for this any group ID I will easily check that what is actually the node actually currently I have. So I don't need to again traverse all the nodes, correct? So I just will filter out that, right? Now suppose after this operation what actually I actually have easily say that from the online vector which actually online or offline, which is online or offline, correct? I can easily say that. Then in the groups vector I can easily say that what is actually the group ID, what is the group ID of X. Okay. Next from this map or anywhere I can say that what is actually the minimum online index and plus also the same group. So it will be like list of set. So why set? Set will store the value in the sorted order. So I can easily say that what is the value present at the front, that will be our answer, right? So first of all go to the map of ID, the current ID, and then go to actually the front begin, right? So this will give us the it will actually help us in login, right? It will take login because it will constant time, particularly the group ID, to know the group ID, and then from to fetch the front value it will take login. Clear? So this is clear. These things we need to solve. Now go to the code. So first of all I have to create the adjacent nodes. So that's why here actually C plus 1 number actually, because why actually they mentioned that 1 to C number actually nodes are labeled as 1 to C. So that's why I have actually taken a vector of C plus 1, vector of size C plus 1. Now I am just iterating the connection. That means the edges between, or the connection between U and V. So this is uniterated, so it can be present from U to V and V to U. So I just find out the U and V, then from the U to V I have stored that, and also V to U I have stored that, right? This is simple till now. Next, what do we know? We have to know that which node actually part of which group, and this is actually online and offline. So first of all, I will find out which which node is actually part of which component. So that's why I have to know the take two variable. One is to scene, to visit the nodes only once. So initially it is false, and groups, it ultimately store the group ID for the each node. So that's why size is equal to C plus 1, and I will initialize it with -1. Got it? And the current component count, the current component number or the grid number is 0 initially. So I will just iterate all the nodes or all the substation possible from 1 to C, and I'll check that is this station is visited or not, this power station. So it will be still false. That means this is create a new component. So I'll start visiting from here. So I'll call the DFS function. What it will do, it will visit all the nodes present in the current hierarchy. Okay, and mark all of them as visited as true, and also store the group ID or the grid ID, right? So that's why I'm calling this DFS function. I'm passing what, the current node I adjacent list. We need to visit the adjacent list and adjacent nodes, and this component count, it actually indicate the current group ID or the current component ID. Got it? Part of the node of the part is the current node is part of which component, to know that. So I'll pass that, and the groups to mark here. Ultimately I have to mark here only groups, and the scene to handle the duplicate visitation, right? So that's why I'll call this DFS function. After this DFS is to visit all the nodes in the current hierarchy present, and in the groups vector I have marked all of them, the nodes part of the current component, mark the group ID, store the group ID, right? I have stored the component count, and for the next, the component count, it will be next one. So that's why I increase that. Okay, so just go to the DFS. Later actually I will explain the DFS. Now go to the next. So after this for loop, I have in the group vector, I know that what is the group ID for each power station, right? And another thing we need to know that for easy access, to know that which, if suppose the current X is offline, our current power station is offline, then who can actually resolve that issue? It will resolved by the minimum index or minimum in power station that is present in the current component, right? And also online. So that's why I have to know that which actually node is actually part of current group. So that's why to get the part of which node is part of the current group. So to know that in constant time, I can actually store in the vector of set. So it will actually store create all the number of component groups. So, and for each component group I will store the set. So set will store in the sorted order. So you can just see that I am just iterating all the power station from 1 to C. So I'll check that what is, first of all check the group ID, because our key will be group ID. I want to know that if current power station is offline, then I have to know the other power station that is part of the current group. So that's why our key will be here as a group. So that's why I will first find out what is the group ID for the current power station I. So I will get it from groups. Okay, and insert the current power station ID is I. Okay, so after this for loop in the set vector of set, I actually have against each group ID or the component ID which node actually part of that in the sorted order, right? Set, it will show in the sorted order. Next I have to know the which node actually currently online or offline. So that's why I have taken another vector boolean online. So that will be C plus 1 size, and initially all are actually online. They mention that initially all are actually online. Now I have written a vector of integer answer. So I have taken this vector. I have written that ultimately. So now what I'll do, I will iterate all the queries what actually they've given. So I'll get, first of all I have to identify this is the query of type 1 or type 2. So each query I actually have two things. One is the first number it will be type, and the next will be the node X. So that's why I will get type the Q0 and the X Q1. Okay, so first of all I find the group ID. for this particular node X. Okay, so I can easily get from groups and particularly index X. I will have now the group ID. Now if it is query of type 2, that means simply do the offline. So I'll check that is it still online. So it may happen that repeated cases are possible. So to handle that situation, like first of all, I mark this again offline. Again, I want to remove. I want to again mark this as offline. So it is not a good duplicate, right? So that's why I'll check that is it still online. So then only mark it as offline. So that's why if it is still true, I will mark this as false. Now it is offline. Now I have to adjust the list also, the set. Why? Because in the query number 1, type 1, they mention that if the current query is offline, current node is offline, then we have to choose minimum number of node part of the current group, but that should be online also. That's why if the current node is going to offline, that will not be considered one possible answer. So that's why from that group I have to erase the current node. So that's why this particular group I am removing the current node X, because it will not be resolved by that time, right? So this is the case. The check by itself, if the station is X is offline, that check is resolved by the operational station with the smallest ID. That means we can choose only the power station that actually online means operational, right? So that's why if it is current node is going to offline, so I can't resolve this. So I have to remove from that set. So I'll from this particular group ID, I'll remove the current node. This is clear. This type 2 is clear. Now else it is type 1. That means I have to know that who can resolve my query. So if it is, they mention that first of all I have to check the current node is online or offline. If current node is online, the current node X, that means I can solve this. So I will store the answer of X, right? Answer X will be stored. Else current node is offline. So who can solve that? It can be only solved by the power station is part of the current grid, and also operation means online and with the minimum index. So that's why I have to check that what is the group ID. I can easily find out what is the group ID for the current node X. So I'll check that the set of this group is empty. That means there is no operational power station are there on this particular grid or particular group. So they mention that for that situation we have to return -1. So that's why that time I will show -1. Clear? Else what I have to do? Else who can actually resolve my query? That will be resolved by the smallest. That means we have some power station in the current grid who can solve my query. So who can resolve that? It will be resolved only by the minimum index that actually present. So that's why I'll take only the begin. Begin means the front value, the minimum value is present, minimum index I have for this particular group G. Got it? And I'll store this into the answer vector. Got it? And ultimately after each query I return the answer. Clear? These things will clear. Why actually I am doing the adjusting the current node from the group set also, because it will not be considered, because otherwise it will actually give us the wrong answer, right? So now this DFS function, so it will just traverse, like actually you can just see here that I actually have current node U, adjacent list, and the current group ID part of like current node is part of which group, and the groups, like actually I have to write the for each index, against each index I will store what is the group ID, and the sim, because to handle the duplicate visitation I have to know that this is actually already visited or not. Now first of all I will mark this as true because this is now visited, and the group ID will be whatever group ID actually I have 0, 1. First it will be 0. Next I will visit the adjacent list of the current node U. I will first see that is this already visited? No. Then only I will visit. But here actually you can see that I am passing V. Adjacent list, group ID is still same because this is part of the same group. The V is part of the same group, right? This is clear. Next is groups and sim. Clear? I hope this is clear. If you found this video useful, please like the video, and if you are not subscribed, please subscribe channel. Bye.